Today we're going to learn about parallelograms and the properties of parallelograms. First of all, let's define a parallelogram. A parallelogram is a quadrilateral I didn't spell very good there. It's a quadrilateral, which means it has four sides. And there's rules that goes along with it, which we will learn as we go, and we'll add to this. But the bottom line, it's a type of a quadrilateral. It's a four-sided object, but there's something that makes it unique. Okay? Before we go to those rules, I'm going to go ahead and use the example right here, and we're going to add to it. First of all, I want you to notice the red arrows. You have two sides that have one arrow, and you have two sides that have two arrows. First of all, one of the things that makes a parallelogram is that its opposite sides are parallel. For instance, this side here is opposite to this side here, and they're parallel to each other. Then you have this side here, QR, is parallel to this opposite side over here. That's one condition that makes something a parallelogram. Another thing that makes a parallelogram be a parallelogram is that the opposite sides are congruent. So QR and PS, not only is QR and PS parallel, but they're also congruent. And the other pair of opposite sides, QP, the two tack marks, is congruent to the opposite side, RS. Okay? Now, that's not the only thing. There's some more things going on, okay, with a parallelogram. And we'll get to it the more we go along. Okay? So we've got these two theorems right here. Okay? The first one, which we already talked about this the parallelogram opposite sides theorem. It says if PQRS is a parallelogram, in other words, if they tell you something is a parallelogram, then you know already, because of that, the fact that it's a parallelogram, that PQ, which is this side right here in blue, is congruent to RS. And you also know that QR, which is this side here I'm shading in red, is congruent to the opposite side PS. This rule saying if you have a parallelogram, your opposite sides are congruent. In the next theorem, it says it's the parallelogram opposite angles theorem, which what they're telling you is if your object is a parallelogram, if they tell you that it's a parallelogram, then you know that the opposite angles are congruent. For instance, the first statement they make here, angle P is congruent to angle R. Well, look at angle P and look at angle R. They are opposite each other diagonally. That's what you need to think of as far as being opposite with the angles, is that the diagonal angles are congruent. That makes them opposite. So P and R are opposite angles and they are congruent. And also, you have Q and S are congruent to each other. Angle Q and angle S, because they're also opposite angles. And you can see, these two angles have the one arc, and they're diagonal or across from each other, and they're congruent. Why? They're congruent because the opposite angles of a parallelogram are congruent. Alright, so let's do an example together. Alright, example 1. Okay. First of all, this is a parallelogram. These four red arrows showing that the opposite sides are parallel, that's what tells us it's a parallelogram. They don't make this statement in the directions and tell us it's a parallelogram, but by them telling us that the opposite sides are parallel, that's what makes it a parallelogram. Well, if it's a parallelogram, didn't we just learn right there with that theorem that if we have a parallelogram, then the opposite sides are congruent? So what do we know? Well, we know that this side here, that is x plus 4, and this side here, that is 12, aren't those two things congruent or equal? So, if we want to find x, we just simply put x plus 4 and set it equal to 12, and solve for x. So we would subtract 4. Okay, eliminates that from that side, and we're left with x equals 8. And to check our work, what's 8 plus 4? That's right, 8 plus 4 is 12. And this side is 12, and that side is 12. And they must be if it's a parallelogram. Now look at the y, at where we have the y at. Okay, the missing value for y. It's an angle measure. Well, look at this angle across it. That is 65 degrees. Aren't those opposite angles in a parallelogram? What did we learn right here in that theorem right above about the opposite angles of a parallelogram? They're congruent. So we'll set those two things equal and solve. And fortunately for you, y equals 65. There's nothing to do to y. That is what those two angles equal. They both equal 65. And so y equals 65. All right. So let's do one more together. Okay. So number one, they want us to find FG and angle G. Okay. And they give you the answers right here, so that kind of helps you kind of know what you're supposed to get. But let's go ahead and look at it. They're not even asking us to solve anything. Really, aren't they just asking us to figure out the information? For instance, FG. FG is this side right here. Well, they don't give us anything, but since this is a parallelogram, isn't it congruent to its opposite side? So isn't GF equal to HE? And since HE equals 8, what does FG equal? It equals 8. And then they want us to find angle G. Well, angle G is this angle right here that I'm shading in red. Okay. Well, what do we know about angles of a parallelogram? Well, right now all we know is that the opposite angles of a parallelogram are congruent. So, since angle G and angle E are opposite angles, they're congruent, and since angle E equals 60 degrees, angle G also equals 60 degrees. So stop your video right here, and I want you to go ahead and do example number 2 on your own. And I know you have the answers already, but I still want you to try to solve and come up with what x equals and come up with what y equals. When you get the answer correct, raise your hand and let me come by and see your work. Okay, so now we have 2 more theorems. Now remember, as of right now, we have if the opposite sides are, if it's a parallelogram, the opposite sides are congruent. Remember, that's how we found FG. Okay, and then we also know if the opposite angles are congruent. That's how we found angle G. Well, now we've got 2 more theorems. The first one is this, the parallelogram consecutive angles. Remember, consecutive is talking about next to or adjacent in order. Okay, so you got to kind of think of the angles as a clock, and when you have a clock, you usually go clockwise on a clock, so you go around, okay? So in a lot of ways, that's what you're going to do right here. But they tell you that if you're told that you have a parallelogram, then you know that your consecutive angles will add up to equal 180. And so they used the x degrees plus y degrees. Well, I need you to understand what they're talking about right here. For instance, if I started at P, as I start going clockwise, don't I get to Q? From P to Q? Well, P and Q are consecutive angles. So whatever y is and whatever x is, when I add those two together, they must be 180. In other words, consecutive angles, if they add up to be 180, doesn't that mean that they're supplementary? I'm running out of room. Okay? So, and then if I go from Q to R, aren't those consecutive angles? And again, they're going to be supplementary. And if I keep going, R to S, they're consecutive, they're supplementary. And then when I go S and get back to my starting point P, those are supplementary. For example, if I told you that X equaled 120, well then doesn't that mean that Y would have to equal 60? Okay, well let's do this. If X equals 120, if angle Q equals 120, well so does angle S. So this angle is 120 and this angle is 120. Well, how did I figure out that Y equals 60? Well, because the consecutive angles are supplementary. So 120 and 60 is 180. And also, not only are my consecutive angles supplementary, but my opposite angles, as we learned before, aren't they also congruent? For instance, Q and S both equal 120, and they're congruent. And those two angles there, P and R, they equal 60, and they're congruent. So the same rule still applies. Okay, and now your new theorem, and this one, for whatever reason, people struggle with. But if your object is a parallelogram, then the diagonals bisect. In other words, I make this statement: if I have a parallelogram, then QM is congruent to SM. Well, QM and SM, they're the two pieces of the diagonal here that I'm circling in blue. Those two pieces are congruent. And also, they tell you that PM is congruent to RM. Well, PM is the two pieces of this diagonal that has the two tag marks that are congruent. Well, if I have a parallelogram, my diagonals, they bisect each other. The diagonals of a parallelogram bisect each other. Now, we've dealt with the word bisect all year. When something is bisected, whether it's an angle or whether it's a segment, what is something that's bisecting something doing? That's right, it's cutting it in half, or it's cutting it to two equal parts. So when you look at point M right here in this diagram, what does that make M? A midpoint, right? Because since the diagonals bisect each other, well, that means the point of intersection, which is point M, okay, point M, which is right there, okay, that is the midpoint of both segments, meaning it cuts PR in half into two equal segments, and it cuts QS, that diagonal, into two congruent segments. Okay, what I'd like for you to do right now is I would like for you to do this example right here that I'm putting the red arrow by. I'd like for you to do that example right there and answer those questions. Okay, they're wanting you to find an angle measure, and they're talking about for this diagram of this lamp right here. So go ahead and work on that on yourself. And when you have what you think is an answer, or if you get stuck, raise your hand and I'll come by and we'll check and see what your answer is, or try to get you unstuck. Okay, so I know you see this next thing, and it's a two-column proof, and that freaks you guys out, but it really shouldn't. First of all, you got to know if it's a two-column proof from the beginning of the year, you have your statement column on the left. I'm going to work on crossing my T's. And then your right-hand column is your reasons column. Okay? Well, remember, your first statement of any proof is always the given information, which is this stuff right here. Okay? So we're going to go ahead and write that here. A, B, C, D, and G, D, E, F, that's a G, are parallelograms. Well, because I'm running out of spoon, I'm going to kind of draw a parallelogram to make a symbol. And what would be my reason? Okay, well, the first reason is given. Okay, and so let's look what they want us to prove. They want us to prove that angle B, this angle here, and angle F, this angle here, okay, are congruent to each other. Now, these aren't even the same object, but remember the very first statement, or the first given piece of information, is that this larger object is a parallelogram, and this smaller object is also a parallelogram, so the same rules apply. Well, let me ask you a question. Since the objects are parallelograms, isn't angle B equal and congruent to angle D? Yeah, because they're opposite angles, right? And also, in the other parallelogram, the smaller one, isn't angle F congruent to angle D? Those two angles there. Right, they're congruent because they're opposite angles. Why do we know they're congruent? Because these two objects we were told that these two objects were parallelograms. So we know those opposite angles are congruent. So that's the first statement we're going to make. Okay? We're going to say that angle B is congruent to angle D. Sorry, my B didn't show up very good. And that angle D is also congruent to angle F. Okay? Now, and our reason would be that the opposite, I'm going to abbreviate, but our opposite angles are congruent in a parallelogram. And that's my parallelogram symbol right here. Okay, that's my parallelogram symbol. Okay, so we've got that. We're basically 2 steps away. All right, our next statement. We need to go ahead and say something about angle D. Isn't angle D, this angle right here, and this angle right here, isn't angle D congruent to itself? You could use, you really couldn't use a reflection property, but where angle D is in those 2 parallelograms, the smaller one and the larger one, isn't angle D, or the 2 angles that have D as a vertex, aren't they vertical angles? And what did we learn about vertical angles? That vertical angles are congruent. Oh, something from first semester showing up again. So we will put angle D is congruent to angle D, and our reason is, you can just put vertical angles, it'd be fine. But vertical angles are congruent. Okay? So now we're ready for our last thing, which, remember, our last statement is always the part they're asking us to prove that angle B is congruent to angle F. Well, this goes back to something that we did first semester. Now, let's look at this statement right here. We said that angle B, this angle here that I'm circling in red, and this part of angle D is congruent to each other because they were opposite angles in a parallelogram. And also, we said that this angle D is congruent to angle F in the smaller parallelogram. And then we also said that D was congruent to D, right? Because they were vertical angles. Well, one piece, and then we'll think about this. This goes back to when we learned 3 properties. That if one piece is congruent to the second piece, which the first piece being angle B and the second piece being angle D, and then angle D, remember this was a D, I had some bad drawing there. If angle D, which is the second piece, is congruent to a third piece, which is F, then what do we know about the first and third piece? And isn't that what we have right here in this statement? The first piece is angle B, and angle F is a third piece. Transitive property. Alright, so real quick, I want you to pause and I want you to do monitoring progress, number 3 there, that what if. And when you come up with an answer, raise your hand and I'll come by and check and see what you did. Alright, well, you've got a couple more theorems, but they're really not new. Look at the very first one, this one right here. It's a converse, which means it's actually something that is opposite that we've already talked about. And we have already talked about the opposite sides, because before, on the first page of notes, we said that if it was a parallelogram, the opposite sides were congruent. Well, now look at this. Now they're saying that AB, this side right here, is congruent to this opposite side over here, CD. And then it's also saying that this side here, BC, is congruent to DA, this side over here. Excuse me. So our opposite sides are congruent. Well, if our opposite sides are congruent, then what do we know about this object? It's a parallelogram. So it's really just saying the same thing. It's just before it was the object was a parallelogram, so you have this. Well, now it's saying the opposite sides are congruent, so it's a parallelogram. If you look at the next theorem to the right, this one here, again, notice it's a converse. And it's talking about the opposite angles. Well, in the previous page, if we were told that it was a parallelogram, we knew the opposite angles were congruent. Well, here, okay, angle A and angle C, they tell us are congruent. They're opposite angles. And then they also tell us that angle B and angle D are congruent, and they're opposite angles. So since the opposite angles are congruent, then the object is a parallelogram. So I want you to do example 2, and when you get an answer, I want you to raise your hand and I'll come by and help you. I will give you a little heads up. They want you to find x and y. Well, first of all, they tell you right here that this is a parallelogram. PQRS is a parallelogram. So you know some stuff about something if it's a parallelogram. Well, let's look at the information. My x's and my y's, they're opposite sides. And so remember, you know the opposite sides are equal. Now there is one issue. When you go to this side over here and this side over here, now they are congruent or equal to each other, but one of them has a y and one of them has an x. So you're really not going to be able to start there first. So really, wouldn't the place to be to start would be these two things, because those two things are equal and they both have x's. So you could find x, and then once you found x with these two equations here, okay, then you know what x is. Well, then couldn't you plug it in for that x? And then that would allow you to find y. So when you have an answer for x and y, raise your hand and I'll come and help you. Alright, so let's do this first one together here, the mod in progress. Okay, and they tell us that we have this quadrilateral, which what does quadrilateral mean? It means the object has 4 sides. That's all we know about it. We don't know anything else. We don't know if it's a parallelogram or anything. But they give us the points, what this quadrilateral will be. It's WXYZ. They give us the angle measure for angle W, angle X, and angle Y. And they want us to find what angle Z equals. Okay? They want to know, is this WXYZ, is it a parallelogram? They want us to explain the reason. Well, first of all, let's go ahead and make a drawing of this object. So I'm going to draw an object, and I'll go ahead and draw it in the shape of a possible parallelogram. Okay? And I'm going to go ahead and plot my letters, and just the way they named it, that's the way I start. Now, it doesn't matter where I start with W, okay, but I'm going to go ahead and I'm just going to put W right there, and then I'm just going to go like a clock and go clockwise. So X, Y, and Z. Okay? Well, so I've got the importer. So now what I'm going to do is I'm going to put my 42 degrees. So angle W is 42. Angle X is 138. Make a better 8 there. Okay, I'm going to change colors. And then they tell me the angle Y is 42. So from what we did in the last lesson, we could find this missing angle, because in a quadrilateral, don't the 4 angles have to add up to a certain total? And if you don't know about a quadrilateral, which you should by now, you could still use that formula, which is, remember, n, which is the number of sides. That was ugly. Let me redo that. N minus 2 times 180. Well, we know we have 4 sides. So 4 minus 2 is 2 times 180. Okay, and that gives us 360 degrees. Well, we know 3 of our angles, so couldn't we add those things up? So if we did 42 and 42, that would be 84. And then we still have the 138 left. Add those two together. See, 8 and 4, that would be 12. Carry the 1. 3 plus 8 is 11. Plus 1 makes 12. And so then we would have 222. So we have 222 degrees used up out of our 360. So we'll take our total degree measure and subtract. And when we do that, you should get 138 degrees. So that means that this missing angle, angle Z, equals 138 degrees. Well, is this object, the way it's written, is it a parallelogram? Well, first of all, look at the opposite angles. Look at angle X and angle Z. They're congruent. Look at angle W and angle Y. They're congruent. So if the opposite angles are congruent, then it's a parallelogram. So that would be your reasoning. Yes, it is a parallelogram because the opposite angles are congruent. Also, if you did your consecutive angles, for instance, angle W and angle X, if you add 138 and 42, you get 180. Remember, consecutive angles are supplementary. Okay, so a couple more theorems. We're almost done. This first one here is the opposite sides parallel congruence theorem. And what it's saying by these things, by these markings, is that if BC is parallel to AD and BC is congruent to AD, then the object is a parallelogram. In other words, I have one pair of opposite sides that are congruent and parallel. So if I just have at least that information, I know that the whole thing is a parallelogram, which would mean the other set of opposite sides were parallel and congruent, opposite angles are congruent, and so forth. Okay? So you don't need all the markings. This is enough information right here to show that they are a parallelogram. Then I have my diagonals converse, which it says if BD and AC bisect each other, then it's a parallelogram, which this is the converse, because a while ago you were told if my object was a parallelogram that the diagonals bisect each other. Well, here they're saying if they tell you the diagonals bisect each other, then it's a parallelogram. And remember what bisect does. That means that where they intersect, right here where I'm circling in black, that is a midpoint of both segments or both diagonals, meaning it's making two, it's cutting both diagonals exactly in half. So I want you to pause the video, do example 4, okay, and when you come up with an answer, raise your hand and I'll check and see how you're doing. I also want you to do example 6 as well. So go do it, and when you're done with that, 5 and the previous one and this one, go ahead and raise your hand. All right, the last page. Ways to prove that your quadrilateral is a parallelogram. Now remember, all parallelograms are quadrilaterals, okay? Because all you have to be a quadrilateral is what? You just have to have 4 sides. So, and every quadrilateral has 4 sides, and every parallelogram has 4 sides. But look at the diagrams in each one of the boxes at the right. Okay. For instance, look at the markings that is on the very first one. Why would that quadrilateral be a parallelogram? Because the opposite sides, I'm going to abbreviate, the opposite sides are parallel. Okay, go to the next one. Why would this be? Why would that be a parallelogram? Because the opposite sides are congruent. Okay, and I want you to do this one your own. I want you to do the third one on your own. And so we'll come back to that here in a little bit, and I'll do the next one. So now we're talking about this one I'm going to do with you. Why is that a parallelogram? Well, notice they don't tell us anything about this side or this side. We know nothing about those two sides. But remember, we just learned a theorem about an object, a parallelogram, that if we have one pair of sides that are parallel and congruent, then it's a parallelogram. And don't we have that? Isn't this side opposite to that side? Yes. And we are told that those sides are parallel, and we're also told that those sides are congruent. So, one pair opposite sides, congruent, and parallel. Remember, that's your parallel symbol. And I also want you to do this last one as well. So, when you have figured out what the reason is for the red arrow and the blue arrow, raise your hand and I'll come by and see if you're right. And then after that, we can turn in your notes, get your daily grade, and you can maybe begin the lesson.